To understand the working of impulse, that is the generator I use to get the energy out of the sea, I'm using Victor Sahlberg's book, the Water Wizard, and Victor was a great one on which I believe he is right. What is in the cosmos, the solar system, is also on the Earth. As you can see, the spirals there. Now you get the same thing up here in the concave of this wave. And in impulse, when I had to make impulse there, I needed to be able to bring two waves together so they actually clashed, like so. So we actually bring the water together. So in the this model here that you can see, which is a bit hard to turn with a finger, the water hits here and spins it. And because it's brought in together, we compress the water, and you can't compress water and it explodes out. Now this is the one that I usually use. I'll be using in the top of the pyramids and all that. And you can use it in hydro systems and all that, because it'll be extremely efficient. This area here, we can have our generator in, or otherwise we can put the generator in the ball itself, like when we pull her out to pieces, which I'm just doing now. So that just leaves the hollow pipe. We're left with the impulse ball. And you can see how the impulse ball spins very freely. And what happens there, because the water hits here, and the centrifugal force pushes it in. When it gets to the other side, it throws the water out. So the water comes in and pushes down here, and we actually pressurise the water from either side. And because it's so precise, the fins, like anything in nature, because I've had to copy nature, anything in nature's got to be so precise. The only way we're actually going to get the precise measurements in there, because this is actually that part there. This is what people have actually seen me wear this around the town. They always say, "What is it, Rob?" Because I wear it around the town as a medal. It's just to remind me that I haven't finished getting impulse up, and because nothing jams in nature at 27.5 degrees, as you can see. Little finger won't jam, another finger won't jam. It'll always be thrown out. And it's nature's way of not jamming anything. And a lot of things in nature use this precise angle so they don't jam. So by using a series of these, we can make up that. Unfortunately, technology is going to allow us to make these up, because with 3D printing, it is going to be quite possible to make these balls up now, because the mates, when I first showed them, I said, I want to be able to lay this out. And they said, can't be done, Rob, our machines won't do it. But now we've got 3D printing, we can build virtually anything we want. And we can also, in the 3D printing, we can have the inside of the ball hollow, and that's where we can put the generator in if we choose. And instead of the shaft of the generator turning, it stays rigid like so, and the ball itself with the generator in it, it's the part that turns. So that's how we're going to get it. And remember, when we bring the two waves together to clash them like so, we're actually compressing water. Now, because you can't compress water, you're not going to lose heat, and it's going to come out, because like any compressor, when you compress water or air or anything like that, it actually comes out cooler. It's hot when it hits the here, but it actually comes out cooler, so we're not going to lose any energy at all. Unlike the generators at the present stage that bring the water over and they hit the outside of the casing of the thing, and that's where we get friction that drives it, and that's where you lose a lot of your energy in heat. And the less energy you can lose in heat, the better it is. So this impulse ball will be as close to cold fusion as we can get it there with our present technology. And this has been carved out of polystyrene balls, so you can imagine it's been pretty hard to carve out. And all those other ones that I've got on the on all the other demonstration there for the tidal energy and all that I use, I've had to carve them singly by hand with a pocket knife, and that's they are not precise, but they're there to give a rough region. So this is what we're sort of looking at. Thank you.